make sure we fit in a lot of thoughtful discussion. I'm just going to jump into the details. I think that the first question that the paper covers very well is what are hybrid smart contracts, how they're going to enable something beyond what smart contracts do today. And I'd be thrilled to hear everybody's point of view on that, maybe starting with Ari.
I think of hybrid smart contracts as a powerful generalization of a key observation in smart contract systems in general. And that observation is simply that it makes sense in smart contract design for a blockchain to function mainly as an anchor of trust and adjudication layer. There are very good reasons then for significant components of contract logic to run off chain. And a few of those reasons are, first, performance. Off-chain systems can help boost transaction throughput significantly. The desire to connect to off-chain systems. Blockchains, as we all know, don't have internet connections, which is why we need decentralized Oracle networks to begin with. Another reason is confidentiality. Blockchains are transparent by design, which in many settings is a good thing, but transparency, of course, is at odds with confidentiality. If we want both, we want to reconcile these two conflicting goals, then we need off-chain components in smart contracts. There are a whole bunch of other sort of subtle motivations, but those are the main ones, need to source randomness securely and so on and so forth. Hybrid smart contracts, as we define them in the paper, are really a generalized design pattern in which very broad functionalities are available off-chain, but are secured or synchronized using on-chain logic. And we talk in the paper about various ways in which we're going to support them. I'll let Andrew and Lorenz talk about what you can do with hybrid smart contracts. I'll just comment that it's equally important to recognize what you can't do without them. You can't really do much more than issue tokens. And even the token issuance process becomes fraught if you don't have secure random number generation in some cases, especially with NFTs, which we may or may not get to discuss at some point in this panel. Andrew?
So yeah, and I want to explain hybrid smart contracts this way. I think of it as a really natural generalization of what oracles already do. So oracles are mainly about reporting information, and the idea to me of hybrid smart contracts is to generalize that so it's not just reporting on data, but also performing some computations relevant to data. And I think this is a really natural kind of design pattern that makes me think of like edge computing and Hadoop, where the principle is to move computation near to where the data originates. And you get a lot of benefits in general from doing this. Like performance, you could imagine computations that compress data right at where the data feed originates so that whatever eventually gets placed on chain is in a smaller form, so it costs less. Then you also get benefits of simplicity by being able to essentially program what computations are going to happen on the data in exactly the same place that that data feed originates. So I see this as a really natural kind of generalization of the kind of computations that oracles already have to do. So every oracle is already doing some kind of data conversion, taking data from one source, converting it into some format that can be represented on chain in a smart contract. And so if you just think of generalizing that to doing other kinds of computations besides just a minimal data conversion, I think you get this idea of adding some programmability to oracles. And thinking of it as a hybrid smart contract is a really good way to think of that, because you bring along all of the desired qualities that you want with smart contracts, like transparency, accountability, being certain that the computations run in a predictable way, a way that you can check after the fact. You get the output that you want. So you imagine using a smart contract kind of framework in order to express what kind of application computation you want those oracles to run. So to me, it's this kind of very nice generalization that kind of matches a design pattern even that you see in other contexts as well.
Great, thank you. Lorenz, how do you feel about it?
Yeah, I think Ari and Andrew already made some excellent points. So I would say, right, on the one hand, they can enable greater scalability. On the other hand, they can provide capabilities that are not available natively on a blockchain today, such as providing better ordering guarantees through fair sequencing services, or providing secure randomness through BRF, and so on. But I think yet another benefit of hybrid smart contracts that we haven't talked about yet is that as we're moving into a multi-chain world where there's many different blockchains that coexist and have different technological foundations, since Chainlink is blockchain agnostic, hybrid smart contracts allow you to keep a part of your dApp blockchain agnostic as well. And so in this multi-chain world, you can then do less work porting your contract and your dApp over and over to different chains, because you can keep a common core, or what would be an executable on a decentralized Oracle network in the terminology of the white paper, of your dApp that you can keep the same between different blockchains you're targeting with your dApp. So I think that's yet another appealing quality of hybrid smart contracts.
Yeah, I completely agree. I think it's important to note that oracles and decentralized Oracle networks are really more a complement and an enabling technology for blockchains than some kind of full replacement. So the way that I see this is that the on-chain contract holds value, releases that value, creates transparency about the state of the contract, maybe defines key conditions that the contract needs to meet, possibly like what we put together with Mixicals or other similar constructions of these kinds of hybrid smart contracts. But the Oracle is responsible for all of these other basically decentralized services. And I think it is fascinating, all the things that you can build with the additional decentralized services provided by decentralized Oracle networks. But I think they're useful as far as there are smart contracts on various chains that need them. And so I think there's this very important complementary relationship where the on-chain code has its very well-defined and clear and very important and irreplaceable role. And I think the addition of decentralized services to that core code kind of can help that core code actually go to the next level, secure more value, do more useful things for the world's users, which is what I think we're all excited about as co-authors on this paper and as people working on decentralized oracles and Chainlink and so on. So I think the next question then is just to understand this a little bit more, is to consider how you folks see Chainlink already providing a certain form of hybrid smart contracts, or some of the near-term hybrid smart contracts designs where you see logic going into a decentralized Oracle network that you find particularly attractive or useful. And it would be great to hear each of your points of view on which one or what collection of kind of decentralized Oracle network computations you think are going to be particularly attractive or useful or interesting in your opinion.